Going on to topic 4.5, in which we are solving radical equations. Now, the strategy for doing that is to, of course, write out your example, and then you want to eliminate the radical sign. And we do so by looking at our index number of the radical sign and then raising this side of the equation to that power. But if we do it to this side, we must do it to this side. Now, we had mentioned earlier that anytime you have a index number and it's raised to that power, it just becomes the radicand. And this is 64. Now we just solve the equation, subtract 8 from both sides, and we get x equals 56. And if you put 56 in there, the cube root of 56 is 4. So this checks. Now, this next one's a little more complicated, but there's a radical expression and then two more terms. So the protocol for doing this is to get the radical expression all by itself, or we say to isolate the radical. So we're just going to take the 5, positive 5, move it to the other side, and we get x minus 5 then on this side. So we now have the square root of x plus 7. And that same technique to get rid of the radical sign. What is the index number that's there? A 2. So we're going to square this side, and we square the other side. Now here, this just becomes the radicand. Again, if this index number is 2, and we're raising it to the second power, it just becomes the radicand. And now we expand this. Double that, and square that. So this is now a perfect square trinomial that we've expanded that binomial squared. Now we transfer everything from this side to that side. So we end up with a 0 on this side. I'm going to subtract an x, so that gives me then an 11x. And I'm going to subtract 7, so this gives me an 18. Now I have a quadratic equation that's in standard form, and the only method we've had so far to solve it is to factor it. That is, finding the zeros. So this is x, this is x. Factors of 18 that add up to a negative 11 would be a negative 9 and a negative 2. And if I FOIL that, it checks. Now I'm going to equal each of these factors to 0, and if I do, I get x equals 2 here, or x equals 9. Now, an interesting thing is if I put the 2 in here, this becomes a 9. The square root of 9 is 3. 3 plus 5 is 8. Does that equal 2? And the answer is it doesn't. So this is what we call an extraneous root and is not applicable. That's why it's important to check your work. Now if I put a 9 in there, that works out very well. 9 plus 7 is 16. I'm sorry. That's right, 16. The square root of 16 is 4. 4 plus 5 is 9, and that equals 9. So this one does check. And this is the only answer you should put into MATLAB. if you put in this answer, which you got from calculating using this technique, but it doesn't check. So it's what we call an extraneous root. Okay, so that's basically what you do. If you had a radical on this side, you would have to do some squaring. In fact, let's try one like that. Now, when we see something like this, where there are two radicals in an equation, what is the protocol or the strategy? Well, it is to isolate one radical and then go and do the steps to eliminate that radical. So what I'm going to choose is to keep this one on this side, so I get the square root of x minus 12. Now I'm going to take this radical and move it to the other side. So on the other side, by transposition, it just changes its sign. Now we've isolated one of the radicals, so our goal is then to clear that one. We do so by squaring both sides. So this just becomes the radicand, x minus 12. Now we use that special technique of squaring a binomial. Square the first term. Multiply these two together and double it. And square this term, it just becomes a positive x. Now we see we have an x there and an x there, so we can eliminate those by subtracting an x from both sides. Just makes our work a little easier. And I don't know if you can see that in each term there's a common multiple of 4, so we can divide everything by 4 to make the numbers smaller. So we now have here a negative 3 equals a 1 minus the square root of x. So we want to again isolate this square root of x. So we're going to subtract 1. This gives us a negative 4. And this gives us a negative square root of x. Now to eliminate this radical, we square both sides again. And we get 16 equals x. So that's the work we've done following the protocol to solve equations with two radicals in it. Now an interesting thing, if you put 16 into the system, it doesn't work, it doesn't check. So in this case, there is no solution, which is one of the options you would check. Because by doing this process, well, it's not a real number, I guess. It is not I guess that's the choice, is not a real number. Okay, now hopefully I would have picked one that did have a solution, but this one didn't. But that is the process. You isolate one of the radicals, square both sides, expand the binomial that you get, make the numbers smaller, and then isolate the radical again and square both sides. But this answer is not a solution because when you put it into the original equation, it's not a solution. Okay.